Hello everyone! In this video we'll be going over the second experiment, determination of the empirical formula of zinc iodide. The general idea in this lab is that you will be reacting elemental zinc with elemental iodine to create zinc iodide. So this is your first experience coming into lab and setting up a reaction, monitoring it, and learning how you work up and dispose of the materials. Along with that, you'll also then find out the masses of the reactants and masses of the products and use that to determine the empirical formula. And this will then test some of those laws that you've learned in class, but apply it and make sure that it's still accurate in your experiments. So the overall objective is to determine the empirical formula of zinc iodide by experimental means. And with that, we'll include testing and verifying the law of conservation of mass and the law of definite proportions, because you will not create or destroy mass during this reaction, and we'll use that to show that there's a definite proportion of zinc and iodine in the product zinc iodide. In this reaction, you have zinc, which is a solid, reacting with iodine, which is again a solid, and you'll add methanol as the solvent in this reaction. And methanol won't react in this, but it's simply to dissolve the iodine, and that then facilitates zinc getting oxidized and giving those electrons to iodine to create zinc iodide. In the course of the reaction, you'll see the iodine will dissolve into methanol, and it gives it this brown color. And you'll know the reaction is done because you might notice that there's less and less zinc, the metallic solid at the bottom of the flask. But the iodine will be fully consumed. This is the limiting reagent. And the solution will turn less brown until it's finally colorless. And that's when you know that the iodine has been fully consumed and been fully converted to the zinc iodide. And this will also be fully dissolved inside the methanol. The course of this experiment is for you to determine the values of x and the values of y. And these should be consistent across all of you, and these should be whole numbers. In terms of skills and knowledge, you should learn to practice the careful transfer of material. You need to learn how to not lose any of the material you're using throughout the whole course of the experiment. You need to learn how to carefully pour, how to carefully transfer some of the solid that you'll weigh from the weighing disc into your flask, how to decant, how to move liquids, a number of things that all are about practicing the careful transfer of material. Next, this will be the first time that you'll be using your actual lab notebooks, and you need to learn how to write down your observations and write down the data that you need to in order to write a lab report. In this experiment, we'll give you tables that you can use, but this is the last time we're doing it. From now on, you'll have to learn what information you have to write down and how to construct those tables. So consider this the last day with training wheels. As I mentioned earlier, you're setting up a reaction, and there's some key steps that you'll be learning, including the setup. What flask do you use? Are you heating it? What do you need to be concerned about when you're heating it? Next, you'll be monitoring the reaction. So how do you know how far along the reaction's progressed? Has it finished yet? Then the workup, which is how do you purify the materials? And finally, the safe disposal. At the end of the experiment, how do you then safely put the correct materials into the correct waste containers? The general workflow of this experiment is that you will have in a flask zinc and iodine and methanol. And it's very important that you accurately know the mass of zinc and the mass of iodine in the flask before you start. So because of this, you need to get the mass of your flask known perfectly. The flask you use has to be clean and it has to be dry. We don't want to incorporate any mass of water in the flask, because that will throw off your entire calculations at the end. So you'll determine the mass of a very clean flask You'll add the zinc to the flask and determine that mass to then determine the mass of the zinc. Then in that same flask, you'll add iodine, and then similarly with difference, determine the mass of the iodine. And this is how we accurately determine the amount of zinc and the amount of iodine in our reaction vessel. Then you heat this up. The zinc will react with the iodine, forming zinc iodide. As I said earlier, the iodine is a limiting reagent, so there will still be some zinc left over. And the zinc will never dissolve in the methanol, but the iodine and the product zinc iodide will. We next want to separate out that leftover zinc from the zinc iodide. So you're going to decant off the methanol that has that dissolved zinc iodide, and you're going to leave behind that zinc as a solid. Now we want to be sure that you fully collect all of the product, because you don't want to leave any of that zinc iodide behind. And simply pouring off the methanol is going to leave behind a lot of methanol that's stuck to the sides or stuck to the solid zinc. So you're going to repeatedly wash that zinc with methanol and then decant. And you're going to do that a total of 3 times, where you'll decant off your initial reaction mixture that has zinc iodide dissolved in it. You'll then add another 5 mL of methanol to that zinc, and then kind of roll it around the flask to make sure it reaches all the sides. Decant again, and again you'll do this a total of 3 times. So any zinc iodide that's coating the sides or on the solid zinc will be moved over in 3 successions. You don't want to add 15 mL because that won't be a full complete conversion. You want to do 3 5 mL washes, and that's a good way to ensure that you've moved everything over. At the end, you'll have a beaker, which again, you'll need to get the mass of accurately with a clean and a dry beaker, and that should have only zinc iodide dissolved in methanol. Your flask will have the unreacted zinc that's left over and will still be wet because you can't completely remove the methanol, but now the methanol should not have any zinc iodide dissolved in it. You'll then heat each of those flasks to dry the zinc in the flask and to get rid of all of that methanol and dry the zinc iodide that you'll have in the beaker. At this point now, you'll have a beaker with dry zinc iodide and a flask with dry zinc. And you're going to then weigh this out in order to accurately determine the mass of the zinc iodide that you've produced and the mass of the unreacted zinc. It will be very easy for you to give up too early in this drawing process. And it's important that you get the mass of the zinc iodide product and not that mass with some methanol that you haven't fully gotten rid of. Because again, any extra mass is going to ruin the calculation of the empirical formula. So there's 2 notes in your lab notebook about how to be sure that you've completely removed the methanol. One is that a good sign that you have a dry solid is if it moves freely when you rotate the flask. If it's wet still, there's still methanol, it will coat the edges, but as it dries, then as you roll the flask, it will move at the bottom. You can consider this, you've seen this with oatmeal. Dry oatmeal moves quite easily in a bowl, but once the oatmeal gets wet, you'll see then it sticks to the sides. The other option you have is you will take your flask, put it on the balance, and measure the mass of that. Then you will then take that off the balance, heat it up again, and if there's any remaining methanol, when you return it to the flask, you'll see a change in mass, which means, again, you didn't completely dry it. If you had already gotten rid of all the methanol, when you add it back, you'll see the same mass before heating and after heating, and that's what you want to see. So I would suggest heating it up for a while and then waiting for it to cool, putting it on the balance, recording the mass. Then returning to the hot plate, heating it up again for another 5 minutes or so, and then returning to the balance. And if the mass has not changed, that means that you've completely gotten rid of all of the methanol and you're ready to continue. So here's the full overview of what you'll be doing. You want to measure the flask, add the zinc, and get the mass of the flask plus the zinc. You'll then add the iodine to get the mass of the flask with the zinc and the iodine, and that will then tell you the mass of the zinc and the mass of the iodine. You then heat that up, waiting for the iodine to fully react, which then causes that solution to turn from brown to colorless. When that's finished, you'll decant off the methanol and wash it 3 separate times with methanol in order to then get in a beaker, which again, you've determined the mass of that beaker. That beaker will have zinc iodide dissolved in methanol, and you'll have a flask of your wet zinc with some traces of methanol. You'll heat both of these up until, after multiple rounds of heating it up and then weighing it again, there's no change in mass. You'll know now that you have dry powders, and you'll be able then, knowing the mass of the beaker plus the zinc iodide and the mass of the beaker before you added anything to it, you'll then have the mass of the zinc iodide product. Similar before, we've already determined the mass of the flask from way at the beginning, and at the end you'll have the mass of the flask with that leftover zinc that did not react. And that will then tell you how much leftover zinc you have. So all of that, the whole lab is for you to get those 4 values: the mass of the zinc, the mass of the iodine, the mass of the leftover zinc, and the mass of the zinc iodide product. And with those 4 pieces of information, you can accurately determine the empirical formula of the zinc iodide product. Now, there's a few intermediary calculations you have to do. First, you have to consider how much zinc is in the zinc iodide product. And you'll know that because the total amount of zinc is the zinc that you added. So consider the mass of the initial zinc. Not all of that zinc will react, so you have to then subtract whatever is left over, and that will then tell you how much zinc is in your product. Now, in theory, if you want to know how much iodine is in the zinc iodide product, it all should react, but you want to make sure, because you don't know if you've lost any of that material, and this is a test as well of your capabilities with your hands in the lab. The accurate way to determine how much iodine is in the iodine product is to take a mass of the product, subtract the amount of zinc that you have determined to be in the product, and that will determine how much iodine is in the product that you have collected. From there, now that you know the mass of the zinc in the zinc iodide and the mass of the iodine in the zinc iodide, you can then use the molar masses to find out the number of moles of zinc and iodine in the zinc iodide product. And with those number of moles, you can then determine the ratio of iodide to zinc. At first, you should report the ratio unrounded, and this will be a measure of how close you are to determining the ratio, and will also give you a hint if you've overestimated or underestimated the amount of either the iodine or the zinc. Then you should round to the whole numbers to best estimate what that ratio, that empirical formula, should be. And this will then give you your final answer to find the empirical formula that's consistent with the data that you have. Next, it's important to see that you've collected all of the mass at the end that you started with. And we'll do this by calculating the percent change in the mass. The total mass before is represented by the mass of the zinc and the mass of the iodine that you added before the reaction. The mass after the reaction is based on the amount of zinc iodide product that you have and the mass of the leftover zinc that you also collect. To calculate the percent change in mass, you'll put the total mass after, that's the zinc iodide and the leftover zinc, minus the total mass before, that's the mass of the zinc and the mass of the iodine you added to your flask, divided by the total mass before times 100 to give you a percentage. The one thing to note is that if the percent change is positive, that means that you gained mass. And if the percent change is negative, that means you lost mass. So it's up to you to consider if that percent change is positive or negative. Consider the different ways that you've introduced error. You can consider if you did not completely move anything over, if you didn't remove all the methanol, if you accidentally spilled something. Consider all the different ways that you may have misrepresented the mass that then changed to an addition or loss of mass over this whole reaction. You'll learn a few important things today that you're going to continue through the rest of the semester and hopefully into the rest of your chemistry career. The first thing is how to use a weigh balance and to weigh solids. What we're going to do is we're going to weigh the solids in a weigh boat and then transfer that to a flask that you have pre-weighed. The reason for this, instead of weighing the solid in the weigh boat and writing that number down, is because you want to be very sure about the mass of the solid that you have added to the flask, because you might lose solid in the transfer. This is called weighing by difference. And as a note, you're going to be heating up your flask to remove the methanol. You do not want to add a hot flask to the balance. We want to treat the balances with respect. So after you take a flask from the hot plate, let it cool down for a while before you add it to the balance. So a quick steps of how to use the balance is you're going to first zero the balance, then you will add your weigh boat, and you can zero it again. Now, it's not important that you write down this number of the weigh boat because it won't affect your calculations, and as soon as we're done, we're going to dispose of the weigh boat. You will then take the weigh boat off the balance. You'll then slowly add zinc to your weigh boat. It's important that you try underestimate how much zinc you'll need and add it back in parts, because you should not put the solid back in the container. If you do, let me know. We can deal with the zinc, but we don't want to contaminate the container. So it's important that you can take some out. If you are under, you should avoid having more than you need. When you estimate that you have the right amount of zinc, you'll put that back on the scale, and you're looking for something around 2 grams. Note that you're not going to write down this mass, and it's a waste of time for you to see exactly 2.000 grams, because that's not going to be the mass that you're going to add to your flask, and that's what you need to write down. So if you see something in that 1.9 to 2.1 range, that's okay. Next, what you're going to do is weigh your flask, and you're going to write down this number. And it's important, again, if the analytical balance gives you 78.750, that you write down all of these numbers, that you don't write 78 grams, you don't drop this 0 and write 78.75. You need to keep every digit the analytical balance gives you. Then you take that flask off of the balance, and you're going to transfer the zinc from the weigh boat to the flask. You can see here the way you do it is the weigh boat is a hexagon shape, and if you pinch opposite sides together, it makes kind of a funnel, and that makes it easy for the solid to fall easily into the Erlenmeyer flask. You can then completely pinch these two sides together and gently flick the weigh boat to encourage any solid to fully fall into the flask. Again, not important that you completely transfer all of the material, but you should do your best to move it all. The important thing is that you then return the flask with the zinc to the balance, and you'll record that mass, again, recording every single digit. And this is how then you get the exact mass of zinc that will be in the reaction, because this is your reaction vessel. Determining the mass before and after your addition is the most accurate way that you'll find out how much zinc is in your reaction. As I said, we'll be providing tables for you for this experiment, and be sure to look at that table, and every time you see something you should write down, be sure to write it down with all the decimal points that the analytical balance gives you. The next important technique is decanting, and that is the way of carefully moving liquids from one container to another. You can see in this image, you want to move the liquids from this beaker to this beaker, and if you're not careful with your pouring, instead of the liquid easily falling out of the beaker, it can stick to the lip and end up falling down the side. And it's very critical you do not lose any liquid to ensure that you get the accurate mass of the zinc iodide product. So the way you do this to decant and make sure you move everything is that you're holding the beaker in your hand. You are then using your first finger or first two fingers to push a stirring rod against the lip. And if the liquid is falling down the bottom, it's most important that there's contact where the liquid is falling out to where the glass of the beaker or the flask is meeting that stirring rod. Then you're holding the flask firmly with all the other fingers. You pour into the beaker, and it should, instead of pouring over the stir bar, fall down the stir bar and drip down off the bottom of it, or the stirring rod, I should say. It's important that you pour slowly, and that will allow it to follow the stirring rod into the flask. You can see the stirring rod is reaching down into this beaker here. If you pour too quickly, it can overcome the stirring rod and flow out of it. So good practice is that you consider where it would flow if there was no stir bar or stirring rod, and make sure that it would fall into the beaker, and ensure that the stirring rod is pointed directly into the flask you're trying to pour into. If you're pouring out of an Erlenmeyer flask, it's a little hard because it's a smaller opening and it doesn't quite have the lip that you need. So this one you have to be very careful and cautious and go slowly, but it's a similar idea. You use one or two fingers to hold the stirring rod against the lip of the flask and pour slowly with the stirring rod pointed into the receptacle you're trying to pour it into. Your methanol will be dispensed with a repipette. You can see the glass bottle here that will contain the methanol, and then on the top there's this spigot with what looks somewhat like a graduated cylinder. Your instructors will control the volume that's dispensed, so don't attempt to change the volume. You can see there's a knob that controls how much volume is dispensed. So leave the knob alone. We'll be in charge of controlling how much volume is dispensed. When you're ready, you'll have your container with the zinc and the iodine in it, and you'll put it up next to the spigot. You can see one hand, again, everything's gloved. It's important to wear gloves and your lab coat. You'll hold your flask at the end of the spigot. With your other hand, you're going to lift up this graduated cylinder. It will go straight up from the bottle. And the cylinder in the middle is going to fill up with solvent. You'll pull up until you feel some resistance, and then you will push it back down, and that will then push the solvent in through the spigot into your container that you're holding. After everyone's got their reaction set up, we will then change the volumes from the 20 ml mark to the 5 ml mark. So you're ready for the washes that will occur. The next thing is to learn how to hold on to hot objects. It's important that you're very cautious when we're using the hot plates because you'll be boiling the methanol, and that's too hot for you to handle without any extra protection. The other thing to note is It's important to have the ability to hold the bottom of the flask and the top. It's not enough to only use one. It's very easy to drop or spill if you're not holding something by the neck and the bottom. So you see here, this person's using tongs to hold the top. You can also use hot hands, which are just gloves that are meant to provide some protection against heat. To give some support for the bottom, this person's using a wire screen, and that's giving the support necessary to hold the bottom up. When you're boiling the methanol on the hot plate, you have to be very careful because methanol is flammable. If you turn it up all the way, it can easily boil over, and even at room temperature, methanol has enough vapors to be flammable. So be careful about overheating it and spilling and causing a fire. So keep it low and be cautious in how high you heat it. Everything that we produce will have to be appropriately put into a waste container. Methanol can be acutely poisonous, so be careful how you use that. Zinc is an irritant, and the zinc iodide can be corrosive if it gets on your skin or into your eye, so be careful with that. The iodine is probably the most hazardous thing you'll use today, but we should completely consume it in the reaction. But again, be cautious, especially at the beginning of the experiment when you're setting up the hot plate and you begin boiling the reaction. At the end, the zinc iodide may be resistant to coming out of the beaker. So in that case, you can use a small amount of 4 molar hydrochloric acid to dissolve it. And if that's the case, let us know, and your instructor should be around to help you. It's also important to note that any rinses that you do should go in a very specific container. You don't want to put this acidic waste into any other of the waste containers. For safety, it's important to wear your safety goggles. You're going to be boiling methanol, and that causes some eye hazards. Almost all of the chemicals we'll use is at least an irritant to your skin, so you have to wear gloves. You should wear your lab coats. I'll check to see if we have aprons for you. And again, because you're doing a lot with liquids, you have to be sure that you're using appropriate footwear to protect all of the skin from the neck down. No gum chewing and no headphones. So today, or for this experiment, you'll be writing down all of your observations and your calculations in your lab notebook. At the end of the lab period, you'll give us the copy of your notebook. So this will be the first time that you'll use your carbonless duplicating notebook. And then at the next week, you'll hand in your full formal lab report. In your lab notebook, you'll see the lab manual, I should say. The Appendix B has a sample full laboratory report, and that will describe, that will illustrate how we think a lab report should be written. And again, if you have any questions, be sure to contact your instructor, and we can walk you through some do's and don'ts about your lab report and how it should look. That's everything. I'll see you in lab, and have a great first reaction in chemistry.